Good afternoon, everyone. I'm Professor Spurti S. Kumar, faculty member from Adarsh Institute of Management and Information Technology. On behalf of Adarsh Group of Institutions, Department of Management, I extend a cordial greetings to all participants who are here with us from various parts of the country. As you all know, we have gathered here for an FDP program on marketing analytics for strategic decisions, a case-based approach. This being the fourth day of our program, we have a distinguished resource person, Dr. Gajapati V, who would be heading the session on place analytics, market basket analysis, and RFM analysis. He was also the resource person for yesterday's session. However, it gives me an immense pleasure in introducing him again for today's session. Dr. Gajapati V is an alumnus from IIMC IIT Hyderabad with over 30 years of experience in research on blockchain, cryptocurrency, business analytics, machine learning, reinforcement learning, management, and inequity. He holds a doctorate in enterprise risk management. He has also worked with MetLife, Royal Sundaram, and currently associated with Presidency University as a professor of business analytics and blockchain. On behalf of our FDP team, I extend a warm welcome to you, sir. Once again, it's truly an honor to have you amongst us.
Thank you. Thank you very much, Professor. Really, this is again another very good welcome. And we will be seeing today about the what you call the market basket optimization. Just I would like to share my files. One minute. Yeah. I'm invoking the Anaconda Navigator. It will take few seconds. I think you may not be able to see that one. I'll be making share screen. Are you able to see my screen? PPT?
Sure.
Are you able to see the PPT?
Yes, now.
Okay, okay, sir. This is market basket analysis, basically, we can call it as market basket optimization. This is using association rules and the familiar package or library is a priori. We will see how it works and all. But this market basket analysis is having huge benefits. Just I would like to show you. Say, for example, this is the scenario. Okay. If this is the scenario, say for example, in this, now this is the product category we are having. See, the basis of this is the market basket analysis is making the association rules. Therefore, the correlation is chiefly or deeply utilized here. The fundamental thing is we are always buying a set of products. That is what is called as basket. Say, whenever I'm going to buy a newspaper, I'm also buying, say, for example, if I buy business line, I'm buying business standard also. That is how. Otherwise, we can say that, say, for example, here I'm putting like this. I'm buying computer. Okay. I think you are able to see. I'm buying computer as well as I'm buying what you call the antivirus package. We usually used to buy it. Another one is I will be buying the printer also. Sometimes I'm buying computer and then antivirus I'm buying, but I'm not buying printer. Whereas you are buying computer, I'm buying printer, I'm not buying antivirus. And then here again, I'm buying computer. See some of the scenarios I'm giving. I'm buying computer. If I buy computer, then I will be buying internet also. And then I'm buying consumables, that is computer consumables I'm buying. These are some of the, see here, if I buy computer, this is a natural. I will be copying this one. If I buy computer, majority times I'm buying antivirus printer, computer antivirus, computer printer I'm having. Again, say for example, another event is coming. Here I'm buying antivirus. Here what we are seeing is association rule we are seeing. Here, this one is called, I'm calling it as TID 1. And then let me check whether it is working or not. TID 2 this is TID 2. TID, T means it is a transaction ID. Okay. Transaction ID 2 this is. And this is 3 and this is 4. Like that I'm buying. So here one transaction means I'm buying computer, antivirus, printer. Like that I'm buying. And this is one transaction. We are calling it or we are indexing it by one transaction, and that is why this is transaction ID is 1 minute. I think it is muted. Okay. It may happen actually. So computer antivirus printer, if I buy, this is one transaction. And the association between computer, antivirus, and the printer, we are finding the association. And of these, say for example, 4 transactions, which type of association is stronger? The association is stronger among computer, antivirus, and printer compared to computer internet consumables, because it is happening only once. If it is so, what benefits in marketing we can get? Anybody, please? If I am able to know, if I know that the consumers are buying, as when the consumers are buying computer, then they will be buying antivirus, and then they will be buying printer. What benefit can I get? Yes.
You can bundle these 3 products and then give them a discount or whatever sales promotion.
Okay, it is a bundle. Okay, this is very good idea. Yes. Anything else after above that one, that is we can give discount? Okay, immediately you are thinking about the discount, but as an entrepreneur, we will not give a discount because it is reducing our profit. But even though it is good, why should I give the discount?
To combat competition.
To combat the competition. Okay.
Because computer operates at very thin margins, so
Okay.
obviously there will be a lot of
yes, true. Okay. Anything else other than this? We can discount the price.
Sir, if we know the basket which the consumer is consuming, then we would be able to plan for the inventory for the sale.
Very good idea. This is also. So for example, if they buy, then we can make the inventory. Therefore, I can say that what is the probability of buying computers today by the customers? If I know that, then what will happen? I will be keeping the antivirus printer and all ready. Am I right, sir? Is it okay? Anything else other than this benefit?
Excuse me, sir. To get the cash before, so to lead the receivable, the cost of giving discount may be lower than the benefit of getting the cash receivable upfront.
Yes. Therefore, you are saying receivable management.
So we can give discount because if we do a cost benefit analysis, then the cost of giving discount, if it is lesser than the benefit of getting cash as receivable, if the benefit exceeds the cost, then we can give the discount.
Okay.
Cash discount.
Okay, cash discount we can give, and the purpose of giving cash discount is? Why should we give the cash discount? Okay, any other things? Say for example, I'm saying this way, say printer sales is low. What can you do? Printer sales is very low. Then what strategy you will do?
Handle it with computer. If they are buying computer and printer, then maybe printer can be.
Yeah, printer
No,
sales
you
is
can
low.
bundle it with the computer.
Okay.
So I will bundle it with the computer, and when they are buying computer and printer together, on printer alone, I can give a discount because that is the one which is not moving as far as I'm concerned.
Okay, but here, this is association, computer, antivirus, printer. It is not a bundle, and you are just understanding the consumer's behavior. And in my business, historic records says that the printer sales is low. What shall I do? Yeah, if the printer sales is low, what people are doing is they are giving discount in other products on the basis of the associations. Sounds good? Or you need explanation? So for example, printer sales is low. Okay, I found that computer printer antivirus. So what I'm doing is I'm giving discount to the computer because computer is having huge margin and the printer is having less margin because my sales is also less. So in that case, what I will do is I will offer discounts on the computer side. Then what will happen? Automatically, they will buy the printer also because it is natural. Association is there. Is it sounds natural or what happens? Hello?
Sir, you mean to say that at least we are able to recover the cost of printer? Is it so? Or we are selling
No. What I see here, I know the association. Now the sales of printer is less.
Okay.
Sales of printer is less. As
But
well as we can make the situation very odd that the printer margin is also low.
True. So there is an
Because
association between the computer sales and printer.
Yes.
So if people buy more computer, automatically the printer sales will increase.
Chances will increase.
Yes, because
So
there is association.
Yes, this is we can say that complement goods also.
Yes, complementary goods.
Complementary goods also. Therefore, this way also you can design the strategies. And this is we are talking about the product based. We can talk in many ways also. See, this is only product based, and therefore this is a simple case. I'm having a bigger, larger size data set. We will see now. And in this act, therefore, we are having association using this association. Therefore, we are finding out all these things. Now we will see what are all the other concepts. Are you able to? Should I expand the size of the PPT? Is it okay now? Spurti madam, please mute the audio, madam. Yes, I can sell more products. The consumers are interested to buy and increase revenues. Very good. This is also a good idea. Dibyendu Nandi has given you a good idea. And this is and therefore this association rule can be used, or association concepts can be used, and association is being digged deeper using the correlation concept. And you see this one, you read this one. This is I buy this and that I buy that also. This is the fundamental principle. You see here I have given in the top of the PPT itself. Okay, therefore buy bread will have higher chance of buying other things also. Therefore an experienced assortment manager will definitely know that having a discount on bread purchase. Therefore what I can do, see, if I know the association, then I can push one product sales so that I will be getting, see this, there are many ways also. We are not considering anything outside our organization. This is the fundamental what you call understanding or assumption we can have. 1 minute, I will be muting. One of the participants is having. No, again, it is also, they are having the control. They are not giving the things. Vijayashree, Please mute your mic, ma. Vijayashree? No, it is not Vijayashree.
Dr. Renuka. Dr. Renuka.
Dr. Renuka and Dubai also, Kirti Dubai. I do not know what is their name. Its name is also not coming. Okay, okay. This we will do this way, and therefore this is actually on the, if you collect the data and if you develop your model, automatically you will come to know that this type of strategies we can take. Okay, the basis of this is this rule mining. This is actually mining technology, data mining technology. And in this data mining technology, we are finding the pattern. What is the common pattern we are having using the association rule mine? Okay, therefore here rule-based machine learning method that helps to uncover meaningful correlations between different products. And this is basis of a co-occurrence in a data set. This co-occurrence is happening naturally. That is why it is coming under the machine learning and unsupervised learning. So this is happening naturally, and I am capturing the pattern here. Okay. Here we have to understand the three important concepts are called as support confidence lift. Okay. We will see one after another now. Okay. Are you able to see my PPT now? Okay. See, this is a little bit, see, in the beginning, it will be very challenging for understanding, but in due course, it will be very easy. And if you go to code part also, it will be very easy. Okay. See, what is support now? It is a basic probability of an event to occur. Say, for example, 100 sales is happening. Of the 100 sales, okay, 10 sales is happening for the printer. 100 sales, 10 sales is happening for the printer. Therefore, here the support is 10 by 100. We can have 10% otherwise. Therefore, here we can say that 10%. Support is 10%. You need not worry about why we are doing now. I will connect all the dots now. But before that, what I'm telling is support is this one. That is how much the particular product is purchased in your total set of product. You see, they have put in another way. Support A is the number of transactions, which includes A divided by the total number of transactions. Okay. Transaction, which includes A divided by the total number of transactions. This is a simple probability. This is very, very simple probability. And this MBA is using probability rules and principles. This is basically. I could not mute it. That is the problem. I could not mute it also. Is it okay now? Okay. Are you okay with the concept of support? Hello? Yeah, there is a question. Okay. No, I did it. Now it is okay. Okay, Kavita, thank you very much. Is it okay, the concept of support? Otherwise, I will show you here. You see here, I'm giving the, okay, I'm going to the edit mode now. Okay. Here, you see here, there are 100 transactions that happened. Out of 100 transactions, okay, 10 transactions is the product what we have, what is in the question now. Therefore, this gives, I'm doing like this. Okay, this gives like this. Therefore, this gives the meaning of, okay. Are you okay with this? Hello? Is it okay?
Yes, sir.
Okay. Then we will go to the what happened? One minute. Now we will go to the next one. See, if we analyze the transaction table, okay, we will, and the table what I have used in this, here I have been using the cookie and all, but if you see this one, yeah, if you see this one, we are having 4. Of these 4, how many you are having all the 3? Yes. Yes. Hello. Okay. So of these 4, how many are having all the 3? How many are having all the 3? Then what is the support now?
3.
8. No, this is TAD1. This is TIT1, TIT2, TIT4. Of this TIT4, this is having full. Okay, these 3 are coming now. And here 3 are coming. Therefore, the count here is 2. And of the 4, total 4. Therefore, 2 by 4, it is 50. Okay. Do you have any problem in this? Should I explain again? Or shall I go ahead? Hello? Okay. Now, okay, this is about the support now. Okay, we will go to the next concept. Okay, this is actually consequent event under the antecedent event. This is consequent event under the antecedent event. This concept is using the conditional probability. This concept is using the conditional probability. Again, I think okay. Now this is using the conditional probability. Okay, so the conditional probability means, say for example, you are buying computer and antivirus. You will not buy antivirus, and because you have bought the antivirus, you will not buy the computer. That way it will not work. Therefore, computer and antivirus, if you are high, okay, then my probability now, what we have done, how many are buying the computer? Okay, say for example, there are 100 customers purchased. Out of 100 customers, say for example, 40 customers have purchased a computer. Okay, this is what we have done so far. Next one is, okay, now that is why it is called the library is being called as a priori. Now what I'm asking is, I bought computer. If I bought computer means, what is the probability of buying antivirus? What is the probability of buying antivirus? Therefore, this we can say that, see, I have been giving the code here. This is, okay, I'm doing like this. Within bracket. What I'm saying is, this is already we have purchased a computer. Okay. What is the probability of buying antivirus? How will you call this one? Probability of computer antivirus. Anybody, please? Okay. Now this is the conditional probability. And what happens is, now if I bought computer means, then what is the antivirus purchasing, the probability of antivirus? Now I'm drawing another idea. You see here, okay, probability of closing, probability of antivirus. What is the probability of buying antivirus? Okay, given purchasing the computer. This is what is our concern. The later probability I have given, this is what is the concern now. What is the probability of buying A given C? Are you getting the point? This is called, yes. This is, yeah. Therefore, the first one is a support and this one is confidence. Now, the next concept what we are going to see is the lift. But if these two are better, then we can go to lift. You see here, therefore, lift is the observed to expected. Okay, how likely an item is purchased when another item is purchased, while controlling for how popular both items are. This is a little bit complex information, and this requires more attention from us. And we need not worry too much about this one. This part I'm postponing, because if you pay more emotional attachment on this, then it will be blocking our development of the calculation of MBA. So be calculated dividing the probability of both of the items occurring together. Both of the items occurring together by the we have to divide it by the product of the probabilities of both the individual items occurring, as if there was no association. Therefore, how can I say, now I am notating it, you see here, this is, okay, probability of. Now, instead of using this probability, I am using directly the concepts, because lift is connecting the support and confidence. Now, you see here, okay, support within bracket, I can put A intersection B. I'm using the set theory. For that, I'm using this way, and then I'm closing. Okay. Now, divided by what is happening? You see here, I'm using S only. Okay. A times S B. Okay, I'm giving a pass now. If there is any question, you please ask me. Sir, that is why yesterday itself, yeah.
Can't we calculate this lift by using confidence as support only?
Yes, we are using. I will tell you another simpler way also. It is C by S. Confidence divided by support. If you calculate, you will get the answer. Otherwise, support A and B divided by support A times support B.
But see, the question is, if lift can be calculated by using only support, like you mentioned this formula. What is the purpose? What is the purpose of the calculating confidence?
Yeah, that is what is my next question. That is given to the forum. This is one way. Now, another way you see here, I call it as, yes, I call it as lift equal to, okay, C by S. Now you give me, otherwise it will be very difficult for me. Support A and B. What is that meaning? You know support S, you know support B. What is meant by support A and B?
In the transaction, both the items are purchasing together.
Very good. That is what is divided by support A times support B. That's all. This is lift. Okay. Otherwise, what you can do is confidence divided by support. Okay. Now, what you have to understand, if the lift goes 1 means, okay, the association is, if the lift is equal to 1 or less than 1 means the association is less. If the lift is greater than 1 means the association is stronger. I'm going very slow. I'm expecting questions from your side also. Therefore, lift is identifying what is the association you are having. Okay. If the association is more, say for example, association is 1.8. What type of strategy? You give me any one of the strategies you can take in the sales.
That basket is appropriate for the, because association is strong and the buyer will purchase both the items.
Yeah, as you said that you can give discount or you can promote one product. I will tell you many strategies are there. Many strategies in HR also they are using the same
bundling.
No, bundling is a different concept. Here we are talking about the item sets. I don't want to use the technical words. So here we are using the item sets. See, I'm going back a little bit. Okay, if it is disturbing, please bear with me. Yeah, here transaction 1 is computer antivirus printer. Here, this is one transaction. And what is the association? Like that, we are having many transactions. You take, for example, Reliance stores, how many transactions they would be having? How many products they are purchasing? They are purchasing about 25,000 rupees, 30,000 rupees every purchase, every week they are purchasing. Therefore, how many products are there? That is why if you real-time data, if you are plugging in, then the decision making is this takes much time, computational time. And the algorithm is also very simplified. Algorithm is very simplified. That's very interesting. That is, we need not go to those areas. What I'm talking is, this is, therefore, what is item set is the 3 things. Computer antivirus printer is the item set. And a computer antivirus is the item set. Computer internet is the item set, and computer internet consumables is another item set. Okay, therefore, I'm seeing the association. For that, I'm using the concepts of support, confidence, under the lift. Now, again, I'm going back to the same thing. Therefore, if I say, say for example, the combined support for 2 products, I have taken only 2 products. It may be extended 3, 4, like that. It will be extended. Therefore, here, for example, for understanding, this is only it is like a foothold, that's all, to have a understanding on the concept, and then we can see how it is working and it is very interesting also how it is working using the a priori in Python itself. This is therefore support A and B divided by support A times support B. This is the simplest one. What this says is, see, yes.
Because I'm referring to your example, sir.
Yes.
In your example, you're considering computer and the antivirus computer and other things which are actually accessories.
Yes, sir.
By default, your example actually considering something which is antecedent and one is consequence. Means something has to be purchased once the purchase of computer is done. Consider a situation wherein both the items are nowhere attached to each other, but still they are preferred to buy together.
Okay.
Can you justify in that situation the formula of support to find out the lift?
That is what I'm telling. Support E and B is, see, what is the association between A and B? Then support A means how many customers are buying computer times how many customers are buying the antivirus. These are all in percentage only. This is giving you relative support. You now read the text matter here. Lift is, you see here, observed to expected. Measures how likely an item is purchased when another item is purchased.
While
items
are
yes,
complementary items.
Yes. Maybe complementary or maybe substitute also. That, see, those things, that is why it is called machine learning. We are not going into that one.
You are right, sir, that either we purchase complementary or the substitutes.
Yes.
This reminds me actually the very famous example of diaper and the beer case.
Yes.
Wherein these two are no, it was found in the Walmart store that on the every weekend they were bought together. So that's where I asked this key, in what situation the formula of confidence is appropriate, in what situation the formula of support is appropriate.
Yes. Say simply, if you go to textile shops, see, you are going for the last Ramjan also. I went to buy some textiles for my grandson and for my daughter-in-law also. So I went and I bought. Immediately they are showing the some clothes, and then we have checked it, and I bought. Say for example, I bought for my grandson, and immediately this person is saying that, sir, here you please come, sir. You can see sarees, pants, shirts like that they are showing. See, this is actually, if anybody buys a children dress, they will buy the pant code. These are all in the retail business. It was there, but nowadays we are using the digital based strategies. So in this, if you are buying two together, and if you are buying only one, and if you are buying another only one, therefore, what is the ratio of lift? So this is while controlling for how popular both items are. See, this is you see here, that is what I have highlighted like this. How likely an item is purchased when another item is purchased, while controlling for how popular both items are. Now, what is my question is, you take denominator like this, okay? If you have interaction between support A and support B, what is support A and support B? You see here, I'm going back. Here we need more understanding, and full understanding we need. Then only you will be getting full idea about this. So you see here, see, support is this one. Say for example, there are two theaters, films are going. Okay, one is Avatar, another one is the this Jackson or Johnson some film has come very recently. Okay, Avatar and Jackson has come. Okay, and now what we have to see, how many customers are saying Avatar is good. How many customers, total customers are 100. How many customers are saying, or they have seen the film? Totally, there are 100 viewers. They have seen the film Avatar. And how many customers are saying that, or viewers are saying that Avatar is good? This is a support. Say, for example, out of 100 viewers, 10 viewers have supported the Avatar. Therefore, I call it as 10%. This is what is there. And 10%, say, for example, another one is there. That one is 5%. Jackson is not that much. Avatar is very good. Therefore, 5% if I say. Okay, 5 out of 100 turned up. Now, if I have 5% times 10%, 5% times 10%, therefore it will give you 50%. What this 50% says are actually 10 times 5, or we can say that 0.1 times 0.5. 0.1 times 0.5. If we have 0.05, if it is 0.05, What this explains about? See, this denominator is saying, okay, this is A and B. This is interaction actually between support A and B. And the lift, if you see confidence divided by support, we can have. This is a simple formula we are having. Confidence divided by support, simple. Okay. Okay, now what I'm doing is we will go ahead. We will go ahead and we will come back. No problem. Okay, we will come back. You see this one. You see this one. See, ID is there. This is what I said, transaction ID. Apples, bread, cheese, dates, things, all these things are there. Okay. This is ID in the first ID. I put apples 1, bread 1. This is, therefore, whichever I have not filled out is 0. Is 0. Therefore, it will be recorded in vector scale. It will be in the vector form. Okay. Now, this is the case. You see here, usually what will happen, this is true, this is true, this is true, this is true, and this is true. T will be given. And whichever is having T will be given 1, other things will be given 0, 0. So this is how we will be seeing. Are you okay? This is a bigger picture I'm showing you, and also I am showing how it will be encoded. I'm slowly taking up to a deeper level of MBA. Is it okay? This matrix form is okay?
Yes, sir.
Okay. No, you can go. Yeah, probability those who watched Bahubali 1 first and due to its effect or influence watched Bahubali 2. Yes. Those who only watched Bahubali 1 and those who only watched Bahubali 2. Correct, exact. Snehal Bhatt is correct. What she has given the idea is correct. Correct it is. That is why PS1 and PS2 is coming. Ponniyin Selvan 1 and Ponniyin Selvan 2 is coming. They are not giving too much gap, time gap. They are not giving too much time gap. Because the effect will be lost. We can say that is why they are, that is why in the English films and all, they are creating part 1, part 2, part 3 like that. Because we are having the same sensations for the next part also. I had a very good experience with respect to the Terminator 1, 2, like that. And the Jackson, this film also, this is part 4 actually, Jackson part 4. Fantastic.
John Wick part 4, sir.
What's it?
John Wick. John Wick 1,
yes,
John Wick
yes,
2,
yes,
John Wick
yes,
3,
yes,
John
yes,
Wick.
yes. Yes, correct. Thank you, sir. So this is how we are approaching now, and this is a bigger picture. Just I have been showing a bigger picture, that's all. Okay, slowly shall we move up?
Can I ask a question, sir?
Yes, please.
Okay, sir. Now in this particular slide where there are various products from apple to ice cream.
Yes.
So now we have to select a base product also now, that with this product, which other product goes?
Oh, yeah. It's a very good, fantastic question. See,
Okay.
there is no that type of analysis.
Okay.
Okay. We are having transaction 1, and then we are having items, and then we are calculating the association. That's all. See, it may be, say, for example, I will tell you another very good example. Say, for example, those who are buying bread. Okay. They are also buying eggs. and then they are buying honey, and then they are buying apple. This order may also be changed. This order may also be changed. Okay, but I'm not starting from apple, bread, cheese, dates. It is not continuously going. The order may be changed. Okay. Now we are seeing frequent patterns, mining frequent patterns. This MBA is basically data mining concept. Okay, frequent patterns, item sets, subsequences, or substructures. We limit our discussion with item sets and subsequences. Substructures, it will be a complex one if we go there. But I will be giving you some note on substructures that appear frequently in your data set. Catalog design, cross-marketing, customer shopping, behavior analysis. For all these purposes, it is being used. If you say frequent patterns is a different way. Item sets are there. And subsequences means in what order they are buying. They're very interesting. In what order they are buying is important there. So frequent patterns, item sets, subsequences are substructures that appear frequently in your data set. So subsequences, we are taking case of in what order you are buying. In item sets, we are not taking order, but we are taking as a basket. That is why it is being called as item sets. Usually in the mining, in the data mining, particularly on the MBA, we are using the word item sets without any space between item and sets. Okay, this is very, very useful for catalog designing. See, there is one case study in the Amazon. If they are changing the set of products, that is, they say, for example, price catalog they are giving. And if I include a particular price in one as a one item in a particular heading, if I change the category, sales is increasing. If I change the category, sales is increasing. Say, for example, I'm searching the books. When I am searching the books in the Amazon, it is giving, through the recommender system, it is giving me Kindle copy is there. Therefore, what this does is, the Kindle copy is actually soft copy. It is not a hard copy, but I have been searching the hard copy books. Therefore, cataloging, or otherwise we can say that the grouping under a particular category is also important for increasing the sales. I expect your comments about it. Cross-marketing, customer shopping behavior analysis. All these things it is being used. Okay. No need to explain this one. Discovering rules in a market basket. A very useful practical application. Rule: if your basket contains apples and cheese, then it is likely to contain bread. Therefore, here two benefits you can take. If apple comes, then I can assure that cheese. And if apple and cheese comes, then the bread will come. Therefore, I can work for all the three products strategically. It is important to talk a measure at this point. Support. Already we have discussed support given in interest items at L. See here some technical words are used. You just check if there is any question, please ask me. The support of L is the percentage transactions that contain L. Items at L is notated here. Example, support of X is 25%. Support of apples bread is 15%. Support of X grapes is 10%. Okay, are you getting the point here?
Yes, we simply count the frequency out of the total one.
Yes. Now, 1 minute. I will be. Oh my God. Yeah, this is an example. And point to point, if the support of an item set with one item, let us say X is P percentage, then the support for an item set which has X as one of the items will always be less than or equal to P percentage. This is assumption. This is a little bit technical. I will be telling what is the meaning of it. Say, for example, what is the percentage of X, support of X? Therefore, support X I will be calling hereafter. Support X is 25%. Okay. Support of grapes is 20%. Support of X and grapes will be less than 20%. That is what it is saying. But it is very important idea, but we will see later, no problem. I'm not going to be on these are all technical side. This is, see, then what you can do, if you understand all these things, then you can teach to your students also in a better way. I will be going to the next thing. It will take some time in the beginning, and then we can do. See, rule, if your basket contains X, it is likely to contain Y. So the rule that is being mentioned is that if your customer buys apples, he is likely to buy bread. Then we are seeing what is the probability of buying it. That is the support. That is the support. And what this confidence says is, okay, see, I'm buying, say, for example, I'm buying one particular product within that purchase. That is the confidence. Otherwise, I can say that, what is the confidence? The word itself explains. Confidence says you that if the association is there, how far it is believable or dependable. That is the confidence. The rule is depicted as apples implies bread. The rule is depicted as apples implied bread. This is in mathematical form. X could be apples, bread, Y dates. Therefore, the rule, if your customer buys apples and breads, he is likely to buy dates. Apples, bread. Okay. Now we are making a connection between apples, breads, and the dates. It is depicted as apples, bread implies dates. This is very important understanding. That is why I have been slowly dragging you on the mathematical side. And because we have to understand all these things to go to the algorithm side. Okay. Measures of rules, confidence of a rule. X implies Y. And you see the confidence, X implies Y. This confidence is very easy now. Support of X and Y divided by support of X. When the if part is true, how often is the then part true? Accuracy, if you will. This is confidence actually. This is related to accuracy. Therefore, support XY divided by support X. Support of XY. Say, for example, you tell me what is the confidence for the past scenario. Support of XY divided by support of X. You see here. You take this example. Support of X. Okay. Support of grapes is 20%. And the support of eggs and grapes, 10%. What is the confidence? I'm adding here support of grapes. Support of grapes equal to 20%. You tell me now what is the confidence? What is the confidence? Support of X and grapes divided by support of X and grapes divided by support of X. So 25 times 20.
Excuse me, sir.
Yes.
Sir, what you are saying is we have been given the support of both the items, grapes and the X.
Yes.
And by using these two items, we are calculating confidence.
Confidence.
Sir, isn't it the case wherein we have to look into the data set whether how many two are picked up together? Because support does not mean that they are being bought together. So even if we have the separate data for support of A and support of B, we cannot say that these two items were purchased together. We have to look at it separately, I think. Maybe I may be wrong. If you can
correct. No. Your point is good, actually. See, support of A means, say I am taking two products. There are 100 sales. Okay. 25 customers purchased X. Support is 25%. This is for example, otherwise I have to use the term transaction. There are 100 transactions. Of that 100 transactions, 25 transactions contains X. Therefore, X divided by total transaction. This is the
X.
Yes, support of X. Or support. Yes. This is okay. Now what I'm telling is, out of 100 customers, okay, are out of 100 transactions, okay, 20 transactions are containing grapes. Okay. Now the support of grapes is 20%. Okay. Now I'm just enhancing. Out of 100 transactions, okay, eggs and grapes together purchased is 10 times. Or 10 transactions of the 100 transactions, eggs and grapes are purchased together. Then support of eggs and grapes is 10%. Are you okay now?
Yes, sir. Yes, sir.
Therefore, it is in the beginning, it will all happen. It is natural. Not only it is to you, it is to me also. Therefore, support of X, support of grapes, support of eggs and grapes. If it is so, then how can I calculate the confidence? Therefore, support of eggs and grapes, okay, support of eggs and grapes divided by support of X times the support of grapes. That is what is this formula is saying, confidence. Okay. Okay. If bread X milk has a support 0.2 and bread X also has a support of 0.15, these are all percentage actually. Okay, this is 20%, this is 15%. The confidence of the rule bread X implies milk. Now I am dragging to a complete association environment. The confidence of the rule bread X implies milk is 1. That is 100% of time a customer buys breads and eggs, bread and eggs, milk is bought as well. The rule is therefore correct for 100% of the transactions. That is what the confidence is saying. The confidence here is 1. Okay. Should we discuss more? You see, bread X milk has a support of 20%. Bread X also has a support of 15%. The confidence bread X implies milk is, you see here, the bread X becomes X, milk becomes Y. Therefore, now bread X milk will be numerator. Bread X milk is 0.2 divided by bread X is 0.15 times milk. Therefore the milk is 1. That is 100%. That is why it is saying. Okay, we are not going to calculate anything in paper or in pencil, anything. It is all the algorithm will do. Okay, just I'm giving you to understand because it will be a start for you. Okay, next one.
Sir,
yes.
If confidence is 100%, do we need to calculate lift?
Yeah. We will see. What is this? We will see now. Yes. Lift of your rule, X implies Y. Lift of rule, X implies Y. You see here, X implies Y. Now, lift X implies Y. How many times more often X and Y occur together than expected? That is why it is a ratio between observed and expected. If they are statistically independent of each other. If it is less than 1, if it is greater than 1. If it is less than 1, it is independent. If it is greater than 1, means it is dependent. Therefore, we expect it should be as much as possible. It should be as much as possible. That is greater than 1. It go beyond. Because the association will be more, therefore you will be making profit. I'm doing positively. Yes, Nagelberg. Yes, ma'am. Don't worry. This is, you will get anyhow some ideas about this one. How many times? Okay, you see lift X implies Y. Support X and Y divided by support of X and support of Y. Lift. Lift is 1 if X and Y are statistically independent of one another. A lift of X implies Y greater than 1 indicates there is some usefulness to the rule. What is the rule? We are finding that if you buy bread, you will buy egg. If you buy bread and egg, you will buy milk. This becomes a very larger data set. A larger value of lift suggests a greater strength of the association between X and Y. 1,000 transactions, milk X 300, milk only 500, X only 400, lift milk X. Is it okay to you?
Sir, mostly it is taking Bayes theorem, sir.
Simple probability. Yeah, Bayes theorem. See, we are talking at, that is why 1,000 transactions it is given now. So far I have talked 100 transactions to accommodate in your analysis. Now it is 1,000 transactions. Out of 1,000 transactions, milk X are 300. Milk only 500, X only 400. Lift milk X is 1.5. Therefore, what this says, we are having, okay, lift milk X, we are having 1.5. What this suggests, please tell me.
Lift 1.5 suggests it is greater than 1, so there is a strong association.
It is greater than 1, therefore it is a having association.
Right, sir.
Therefore, you can make some engineering work. Either you can reduce the price, discount, offer, something else you can give. I have I have studied one article also, in that it is saying that, see, in the retail stores, they will be keeping one product at the entrance, because say, for example, milk and the eggs are purchased together. Therefore, they are keeping the milk at the entrance of the retail store, and they are keeping the eggs at the end of the retail store. Why, my dear professors? Because you purchased milk, then you will be asking the retailer where is the X, and that girl will be telling you that go to the last tray, it will be there like that. Then you will be walking. If you are walking along that, then mosquito repellent will come, and basmati rice will come, and fish, dry fish will come, and dates will come. You will purchase it. This is another strategy they have. That is what this is place analytics. So therefore, I'm thinking that therefore milk and DX are having association, strong association. I want to make this one. What should I do? This lift milk X, I want to make it to 1. What should I do?
Either you should increase the support of both items.
Increase the support of both items.
Yes, sir.
This is 1.5. Therefore, 1.5 means 1.5 divided by 1. Okay. Now I have to increase the individual support.
Right. So
it will become 1.5. It should be. Therefore, what shall I do? Say, for example, I'm giving like this. Okay. See, say, for example, this 0.5 is for this one, milk, right? Milk is say, for example, milk is 3. Okay. It is 300. And X is, how should I put? Milk is 300. If I put milk 300, then what will happen? It is 3%, 0.3 will come. 0.3. If denominator, the first term is 0.3, then 0.4 should be 0. That is, X should be 0. There is no purchase in X. If it is so, therefore, we cannot say that milk and X are having the relationship. Of course, we are making X equal to 0. Are you getting my point? Or should I repeat it?
Okay, sir.
See, we are having numerator 0.3. Denominator 0.5. Lucky. Okay. Now what I'm saying is, you see here, I want to make it 1. 1 means it doesn't have the strong relationship or association. Okay. In what situation it will be? Therefore, there is no purchase in X. Therefore, you make the X purchase 0, and milk is less, 300 only. Therefore, 300 divided by 300 times 0. Therefore, it will become 1, simply. So this is how we are making. Therefore, here you are using support and support mechanism. Now we will go to the next one. Lift test your understanding. 10,000 transactions from an electronics store. 10,000 transactions which has video games, transactions which has, I think, transaction which has 10,000, which has video games is 7,500, transactions which has computer games is 6,000, transactions which has both computer games and video games of 4,000. Okay, rule: computer games, video games, confidence, lift. What is this? You see, I have given, I will be launching this also. Are you able to comprehend this one? Is it okay? Sir. Okay. Okay. You see this one, measure of rules leverage. I think we can avoid this one. How many times more often X and Y occur together? We will come later. And a measure of rules, okay, a priori algorithm. A priori is generally invoked with a minimum support threshold. See, now we are having support, confidence, lift. Support, confidence, lift we are having. We have to specify the support level as well as confidence level. We will see in the code itself. We will be specifying, and if you change, then it will be changing. That is what this support level is saying. So I'm taking only one example because the support is an easier concept to understand. So for example, there are breads purchase, total transaction is 100, and the bread of the total transaction, 20 transactions are containing bread. Therefore, support is 20%. Am I right, sir? Am I right, sir?
Yes, sir. Yes, sir.
Yes, 20% is the support now. Now the question is, if it is 20%, I will be saying that the support is strong. Same, and at the same time, I can say that if it is less than 20%, I will not accept it. Therefore, if it is less than 30% means whichever is having less than 30% will be avoided for the discussion or analysis. So in the same way, confidence. In the same way, confidence. Confidence, if I say that this much of confidence, less than this much confidence, exclude from the analysis. Therefore, I'm specifying what is the level of association. The level of association should be stronger, then only I can take decisions. Say, for example, I'm going to say, I'm going to send a mail. Okay, I'm going to send a mail, promotion mail. How I'm seeing, after seeing the association, I'm sending the mail. This association is there, therefore I'm locating the customers also. For those customers, I'm sending the promotion mail there. If you purchase onion, 50% discount will be for the potato. When you are bringing your ID is this one, you bring this ID, like that I will be telling.
But dear participants, I think there is some network issue with the resource person. I'll just check with you.
Sorry, it was disconnected. I got joined again. Is it okay?
Yes, sir.
Okay. I was disabled upon this screen sharing. Okay. Now, screen sharing enabled, madam. Enable the screen sharing, madam. No, they have not enabling.
Sir, I have enabled, sir.
Yes. Okay, madam. Thank you very much. Okay. So therefore I have to give this is what is that I'm saying. What is the minimum? So I say, for example, I'm going to give gold coin. I'm going to give 10,000 rupees gift means, then I have to say that strong association, super strong association should be there. If the association is so strong, then if you buy, say for example, if you buy 1 kilo of toothpaste, I will be giving you 1 gold coin. 1 kilogram of toothpaste is what their customer will do, but they will buy because gold coin is coming. Just for example, I'm telling. So this is the way we are controlling the support confidence. Okay, are you okay with this? Are you able to hear me? Are you able to hear me or not, please?
Yes, sir. Yes, sir.
Okay. Now we will go to the algorithm. Okay. Now I have invoked this one. Then I'm going to access the things. It's very interesting. I will show but now I'm going to use a different type of data. Okay. Different type of data. I will show first the data and then we will discuss more on this one. Okay. Before that, I will show this type of data. Are you able to see the data now? Excel file? Hello? Hello, are you able to see the data in the Excel
Yes,
file?
sir.
Yes. Yeah. You please see there. First, in a particular transaction or a particular customer is buying shrimp, almonds, avocado, vegetable, green grapes, whole wheat, yams, cottage, like that. Many products are there. You see, I will check how many are there. It is about 20 items that first customer has purchased. She has purchased. And if you see, the third customer has purchased only chutney, that's all. And the fourth customer, turkey and avocado. And like that. The sixth customer, only low fat yogurt. Like that it is there. Okay. And then soup is there, light green and a shallot. French fries only. So this is how it is there. Okay. So this is the data. But I'm not going to use this data, but this is usual data. Therefore, this is how many transactions I'm having. See, how many transactions I am having means I'm having 7,501 transactions I'm having. Are you okay? Are you seeing what is the real-time data it will be? This is the data we have. Okay. So, okay. Okay. This is the first record. But I'm going to see a different one. It's very interesting also. What is that one? You see here. Grocery data set I'm having. It is all CSV files. It is all CSV files. I'm having. It is different. Member. This is transaction, I can say. Transaction ID or member. Okay. And then date I'm having. Okay. And then I'm having the item purchased, tropical fruit. You see here, fruit, vegetable, juice. You see here, packaged fruit, vegetables. Like that it is there. You see here, hamburger meat, root, vegetables. You see here, fruit, vegetable, juice. Just simplified data, rules, buns. If you see this one, packaged fruit, vegetables. Like that it is there. How many transactions I'm having? How many transactions I'm having? How many transactions? You see, it is 38,765 transactions I'm having. It is quite big in the analytics industry. It is not a big one, but this is a good data set actually. This is the data set. Shall I move to the coding part? Now I'm using this market basket analysis. Okay, this is PPT. This is groceries. Yes. Is this data set I'm using. I have given some ideas also. A priori algorithm is one of the most popular algorithms used like that I have given. For this, I am downloading a priori, like that it is there. It is in the same thing. A priori is in the R programming also. So pip install a priori. Okay. Now I have installed this one. Next, I'm using ML extend. Okay, what is this ML extend? We can go here. We can see what is, okay, ML extend. Just I want to know in Python, it is there. What is ML extend in Python? See, ML machine learning extensions is a Python library of useful tools for the day-to-day data science tasks. Source code repository, everything is there. It is GitHub, it is there. And if you see towards data science, ML is a library with interesting tools for data science. It is having many tools. It is very important to keep in your toolkits also. So it is nothing but this is simply a toolkit. That's all. Okay. I have to execute now. Now I am executing. Before that, I will be clearing all the output. All output I am clearing. Okay. Just with the understanding, I'm just invoking this one a priori. Okay. You see the star is there. Are you able to see? I have enlarged it also. If there is any problem, please tell me. Okay. Now ML extend I'm using. ML extend. It is also executed. It is done. Requirement already satisfied because already I have loaded in my system. It is there. You can use in the cloud also, no issue. Now import some necessary modules and read the data sets that we have downloaded from Kaggle. I have taken one data set. The data set name is grocery data set. That is different, downloaded from Kaggle. You can also do, but I will be giving the data set as well as this coding file also, no problem. You see these import pandas, NumPy, Matplotlib, Seaborn, RE. These are all usual packages we are downloading. I'm executing this also. Executed. It is working now. It is also ready now. I'm doing now ML extend. Already we have access to the ML extend, and ML extend is import a priori. Import a priori. ML extend frequent patterns. This is frequent patterns. This part of ML extend, okay, from ML extend frequent patterns we are having. Of that you import a priori. A priori is the algorithm we are having. Why it is a priori? Anybody please? Why we are calling it as a priori? Why we are calling it as a priori algorithm? Anybody please? Because, say for example, I'm buying bread and then I'm buying egg. Okay, then what is the probability of buying bread? This is one concept. Another one is, I am buying, what is the probability of buying egg, bread egg? What is the probability of buying egg? Now, what is the probability of buying egg if I have already purchased the bread? I'm giving a pass. If there is any question, please ask. It is very easy also. Therefore, how can I, in probability terms, how can I say? Say, for example, probability of buying egg given bread. Already I have purchased bread. Then what is the probability of buying? This is being called as priori probability, a priori probability. That is why the package itself a priori. Same thing is in the R programming also. Okay, from ML extend frequent patterns import association rules. We are calling association rules also. For that I'm using ML extend. ML extend pre-processing import transaction encoder. We are doing transaction encoder. We will see how it is happening. From MPL toolkits, mplot 3D effect, we are going to see import access 3D. Import network as NX. It's a very interesting, really now. See, when we are going to execute and get the results, it will be very interesting to perform a market basket analysis implementation with the a priori algorithm. We'll be using the groceries data set from Kaggle. Already we have seen. Okay. Now basket, I'm giving the name basket. This is actually what you call object. I have created this is my own object. You can give any name also here. Therefore, object basket, PD read CSV because it is in CSV file, grocery dataset CSV, display basket head like that I'm having. You see here, I'm having these things. Is it right? This is what we have seen in the Excel file also. You see here, this is for the, if you give the display basket dot head, this is basket is the file name, and head will give you first 5 rows. Since Python starts from 0, it goes up to the number 0 in the index column. Therefore, member number, date, item description, it is given. Is there any question, or shall I move ahead? Hello? Shall I move ahead? Okay. Now, this is, you see the Excel file now. See the same thing we are having. Same thing we are having. Member, date, item description. 3 columns we are having here. Okay, 3 columns we are having. But here, how many columns in Python we are having? 4 columns, including the index. Okay. Now grouping into transactions. Grouping into transactions. All these have been loaded. Now we are creating transactions and grouping into transactions. Okay. Basket item description. Basket dot item description. This item description is a function actually. Okay. Transform, lambda, all these things I have given. Here, what I'm doing is I have been grouping into transactions. I'm grouping into transactions. So one transaction, second transactions like that I'm doing. For that, I'm using encoder, transaction encoder. Encoder equal to transaction encoder. Therefore, I will be using encoder hereafter. Now, transactions equal to PD data frame. I'm using data frame data type. Encoder fit basket. I'm doing fitting here. And transform basket. This is usual machine learning methods and the columns encoded dot columns. Okay. Now we will be seeing a priori. Now I will be executing this one. No result we will be getting. Oh my God, error has come. Transaction encoder is not defined. Okay. 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 Now I'm loading this data. Okay. Now, yes, it is there. Here you have to understand a little bit more now. See, we are actually one after another, we have been annexing our understanding in the MBA type analysis. See here, instant food products, UHT milk, abrasive cleaner. These are all the things, bags. These are all items. See here, 5 rows, 167 columns. What is this 167 columns? All are product. Now the products have gone to the column heading and this is what we are creating the transaction settings. We are encoding into transactions. So on we are making it as transaction actually. So this is actually display transactions head, So what I'm going to do, you see here. Okay, I'm creating one here. What I'm going to do is I'm going to ask what is the length of transactions. Okay, what is the length of transactions? If I ask it, 14,963 rows are there. 14,963 rows are there. How many columns? 167 columns. Therefore, 167 products have been encoded now. Okay, I give you a pass. If there is any question, please ask me. Is there any question? Hello, are you able to hear me? Are you able to hear me?
Yes, sir.
Yes, sir.
Okay. Okay. Now, okay, then I will be going ahead. See, now this is all products. Okay. And this is, if it is purchased, means it will come true. I will check it whether there is any true. Okay. All are false, because this many products have not been. You see here true. Whole milk is true. Whole milk is true in the first transaction. It is coming. Okay. This is called a vector. That is 0 row, the 0 indexed row, it will be having F, 2, F, true, like that it will come. This becomes a vector. This vector will be used for analysis for the MBA analysis. We will see now. Therefore, this is vector. Therefore, here whole milk is there, right? It is, what is this? White bread, whole milk is there. Let us see the data. You see the data, whole milk is there. You see, this is the whole milk 2552 member ID. And 5/1/2015 whole milk is there. Okay. And this is how we have been doing encoding. This is called transaction encoding. Now we will be seeing a priori and association rules. A priori association rules algorithm will be used to generate frequent item sets. Which item sets is frequent? We will be specifying the minimum support to be 6. See, I'm giving minimum support threshold level. Okay, minimum support to be 6 out of total transactions. The association rules are generated and we filter for lift value 1.5. I'm giving support value 6. Already I told you, we have to give the support value. So I have given the support 6. And the lift should be greater than 1.5. Why I am putting 1.5? You can change it also. We will do later. If it is 1.5, then I can see that what is the, whether it is having a strong association. All strong association we will be seeing. Now you see here frequent item sets, a priori transactions, minimum support. 6 divided by length basket. Length basket, therefore, how many is there basket? Therefore, this is giving you in terms of percentage. This is gives you fraction actually. Length basket now. I will be doing like this. You see here, what is the length of the basket? What is the length of the basket? Okay, length of the basket. Length of the basket. Length of the basket is 14,963. This is what is the number of rows we are having. 167 columns we are having. That is 167 products we are having. It is all in columns. And how many transactions? 14,963 transactions are there. Now, what is the 6 I have given? That is, this is what? 6 out of total transactions. Total transaction is 14,963. Okay, 6 means then this will give you support. This will give you support. Support I'm giving 6 out of total transaction. Total transaction is 14,963. Okay, and the 6 is the numerator, means what is this 6? Anybody please? What is this 6? What is this 6? The 6 is support. That is, say for example, whole milk is there or wheat is there. I am giving support to week. 6 means of the 14,963 items, there should be minimum 6 purchase of wheat should be there. Therefore, here what I'm doing is 6 divided by, I'm putting like this. If I put, you see the number. This is what is I'm expecting. This at least 15,000, say for example, round 15,000 transactions are there. Out of 15,000 transactions, minimum 6 should be purchased. 6 transactions should contain that product. Then only it should come for the analysis. Otherwise, leave other transaction, other the product not for analysis. That is what we are doing. Very good. 6 no, not 6 items are found together. 6 items, say for example, I'm taking wheat as a product. What support wheat should have? That is a support wheat. Okay. Say I will be giving in my old explanation, 100 transactions are there. Out of 100 transactions, 6 transactions should be wheat transaction. There should be wheat. Say for example, okay, pickles are there. Of the 100 transactions, pickles are purchased only thrice, means these pickles will be avoided for the analysis. Okay. Now this is therefore frequent item sets. Now I'm executing this one. If I execute this one, it is working. Now you see, this is support, antecedent support, consequent support. Not necessarily, we did not discuss this one. Now support, confidence, lift. All these things have been calculated according to the principles. Are you okay now? See, that is why I said that just understand the concept. You need not compute anything. So buttermilk, what is the support point? This one. What is the confidence? What is the lift? You see lift. Why lift is anything less than 1.5 will not be accepted. Greater than 1.5, because we have given, you see, minimum threshold 1.5 I have given. Lift, metric lift, minimum threshold 1.5. You see here, minimum support 6 I have given. Use column names to maximum length equal to. Okay. Now, therefore, this is how we are having now. Now we will see, this is how we are having support, confidence, lift now. And see, this discussion is concentrating more on the support, confidence, lift, and leverage, conviction, zangs and all left to you. You can do, and you can do, because already time is up now, visualizations. How I am going to do, for this I have used the what you call the SNS package. Okay, Cbond package I have used. And I have done all these things, weight grade, support, confidence, lift, all these things I have given. And I'm using 3D distribution now. We will see the 3D effect of this picture. It's a fantastic explanation. See, it is working now. It is a bigger one, really. You see now, this is a fantastic one. And first time when I was seeing, I was excited, really. This is 3D view. Okay, on the x-axis we are having support, on the y-axis we are having confidence, and it is 3D support actually. See, if it should be on the right top, it should be on the right top. Okay, but these are all staying. You have to have a 3D view. See, this is one wall, this is another wall, this is ground. If it is so, what happens? These are all distances. You can see these are all the points like that we are having. You see now, this is actually support confidence analysis we are having. Support confidence analysis. Okay. Now we will be seeing the network graph. Using the network graph. This network graph is really very interesting. I have referred here in material. I got it. It is nothing. I have not designed this network graph. You see, this one is long code part in this code snippet itself. Okay. Now definition drawn network also. See, drawn network I have done. It is a repetitive work. It is a repetitive work I have here. And then now I have been executing this one. You see now the graph you are having. This is fantastic. This is fantastic. We can increase the size also on drawn network rules. Okay, not necessary. Are you able to see this one? I'm expanding. Are you able to see this one? Hello?
Yes, sir. Yes, sir. We are able to see, sir.
Yes, because we are lacking time also. You see, what is this graph network it is? You please understand the word network it is. What is this explains? What this explains is, say for example, you take whole milk. Are you able to see my cursor? Whole milk. Okay, whole milk. Are you able to see? Are you able to see my cursor? Please.
Yes, sir. Yes, sir.
Yes, this whole milk is purchased. Before that, what is purchased means R7. R7. Before R7, sweetener is purchased. Therefore, sweetener is purchased, then R7 is purchased, then whole milk is purchased, then R6 is purchased. Like that it is there. A network. That is why it is being called as network. That is why it is being called as network, sir. Is it okay? Now, can you explain anything else? Very interesting.
Consequence और antecedent change हो जाते हैं.
Pardon?
Network में. In case of network, जो हमने market basket में study किया था, consequent and antecedents बदल जाते हैं. For example, in this case, yes, sir.
See, we need for the market basket analysis itself, we need 4 days actually. See here, this is the way. So you can see the influence and then antecedents, consequence, you can see. That's very interesting. Okay, we will come back again to this. And business application, milk rules, consequence, as type it. Okay, just I'm executing because you don't have time now. Business application, you see here antecedents, brandy. You see interesting observation is there. Antecedents is brandy, consequence is whole milk. Hello, my dear faculty. You see here brandy and whole milk is coming together. I don't believe this also. Do you believe this one? Those people who are buying brandy is buying milk next. Is it happening? Is it true?
Maybe, sir, this is the weekend data.
People
are preparing for weekends.
Yes. And another one is antecedent support is also 0.002540. Consequent support is also good. You see support, confidence, lift, you see, lift, you see. Hello, what is the matter I have done, you know? Here, you see, I have used in ascending order, using the lift. So it is coming ascending order. Display milk head I have given. I can remove this head now. You see now, I will be getting full things. 6 transactions are showing. This is lift is 1.5, 1.5. Why 7 is not there? In the index 0, 1, 2, 3, 4, 5, 6. Why 7 is not there? Anybody please? Why 7 is not there? 7 is not there. If I go to 7, then that will go below, the lift will go below 1.5. Because I have set the limit of greater than 1.5. Are you getting my point? Is it okay?
Yes, sir.
Yes. Lift is greater than 1 means this is having strong association. Now, therefore, 6 only available. Now you can strategize. You tell me any one of the marketing strategy using this data set.
This is the gym.
Give me any one of the marketing strategy using this one.
Sir, shelf allocation, regarding self allocation, we can, do something regarding what product.
Very good, very good, very good. Anything you can tell, anything you can tell. Any simple strategy you can tell, no issue.
So like for health conscious, artificial sweetener and whole milk can be.
Okay, no, see, we will be, the health conscious means then we have to include other concepts. Now what I'm telling is, I would like to increase the profit for my company. What should I do?
Sales increase करना तो सर को एक basket बना सकते हैं इनका मिलाकर के.
I know little Hindi. That is
okay. Sorry, sir. Can we create a basket? Can we create a basket that can increase the sale?
Okay, what basket you will create? Correct. Ravi Mohan sir is there?
Can we offer discount?
Yes, sir. I am there.
Yes, sir. Yes, sir. Please tell me what strategy will you give, sir? Yes, Pankaj Chauhan is telling something.
I was telling, sir, that can we still work out on some discount, some sort of discount, thereby increasing the sales we can
discount. If you give discount for what, which product you will give discount?
For the entire basket.
The entire basket means what?
Like for example, if we can place these 1.8, 1.8 and second, third, and fourth.
Okay, second, third, and fourth. Your canned fruit, whole milk, syrup, whole milk, artif, sweetener, whole milk. This is the baskets. Sir. 3 biscuits.
Because the lift is 1.5, which is close to 2.
Okay, very good.
To close the second one, the first one, brandy and whole milk. Although the lift is very high, but I don't know how many people will actually, in terms of numbers, how many people will pick up this.
And they will do. What is the problem there? See, that is what I'm telling. This is machine learning. Nobody is interfering here. Another one is it is unsupervised. We have not interfered anything in this part. It is just on the basis of data. You see, antecedents is brandy, consequence is whole milk. We will see the network. Whole milk. Okay. Antecedents, I think, see whole milk. Consequences. Yeah.
R9,
see,
R7.
Say for example, we will check because we are not having the full names R5 like that. It is there, so we can have see something else we have to see. To whole milk, everything is coming. Whole milk softener is there. Whole milk softener. Whole milk softener, I think. See, therefore, here you can see which one is antecedent, which one is consequent. So with this graph itself, you can work out. So what you can do is, say, for example, you see, start from this. If you start from this R7.
Sweetener.
Yes.
That is the one which is your whole
connecting
milk.
Many products.
No, whole milk sweetener is equivalent to this artificial sweetener.
Okay. So now what is your strategy? You please tell Professor. See, artificial sweetener is there. This will be purchased first, and then R7 will be purchased, and then whole milk will be purchased.
Anybody who is buying whole milk will be using it for making any beverage, tea or coffee.
Yes.
So naturally, they need the artificial sweetener.
Yes. See here now, what shall we do? What, say for example, if I want to increase the sales of R6, this is actually brandy. If I increase the brandy, anywhere is there brandy? Okay. Canned beer is there.
Brandy
you see here canned beer. Canned beer is there and R9 is there. Canned beer and then R8 is there. And R8 again precedent is the baking powder or baking powder. And baking powder is having the precedent to R9. And R9 is, that's all. Therefore, R9 is having precedent canned beer. Like that it is, the cycle is there. Therefore, if you know this, then what you can do, you can, either you can increase one product's sales or you can give any discount so that you can increase other products purchase also. That is how. So if you see this one, then what I will do is I will give a discount on whole milk, because that will not affect my huge revenue. I will give discount for whole milk. Therefore, milk is less price. These people are usually buying brandy also. Therefore, they will buy brandy. Otherwise, if I give discount on brandy, I can increase the whole milk. But what is interesting is all consequence are whole milk. All consequence are whole milk, you see. Are you okay?
Yes, sir.
Yes. So whole milk is very important to product. We have to see, because lift is more than 1.5, and particularly brandy whole milk is lift is 2.17. Very, very fabulous. It's very interesting. Okay, now this is one type of analysis we can have here. Another one, what we can do is here we can change the parameters. See, minimum threshold 1.5 now I'm having. Okay, maximum length under. Okay, minimum threshold 1.5 I'm having. I'm reducing it to 1. What will happen? Okay, what will happen now? For that purpose, what I can do, sell, I can go run all above, run all below. You see the network is changed now. You see here also, this is also changed, because I have given one only lift, the list is increased. How many lists have come? 17 items have come. And you can see now, therefore you can give, but what is interesting is still the whole milk is there as consequence. Therefore, whole milk you have to maintain, and there should not be any shortage of stock for whole milk. And again, brandy whole milk stands fast.
Is it possible that we can do an interpretation that this store may be nearby some of the maternity or center?
maybe, and see, after drinking brandy, they may be having hangover. For that, they may be drinking milk also. I do not know really. Sometimes, if I say, for example, if I take brandy, then I will not be having the full meals and all. So that way also we can think. It's all very interesting, isn't it? So if I change the lift, how it happens? If I change the support, what will happen? That and all you can do. I will leave this code to you, and these things you see automatically it changes, and the entire thing is changed now. Using this stuff you can discuss, and same methodology you can use in teaching the same tool to your students also. your students will definitely get impressed, and they will be very much liking on the marketing management training. If there is any question, please ask me. If it is okay, then we can wind it up, because already the time is exact as it is. See, this picture is also changing now. Everything will change. And this picture is also changed. So more concentration is here, this side. That is why we have to increase the lift always. You have to increase the lift always. Okay, no problem. Is it okay? Is there any question? Is there any question?
Excuse me, sir.
Hello? Yes, ma'am. 1 minute.
The network graph is similar to PERT CPM in terms of the nodes and how the
Yeah, please tell me, madam, your network?
network graph,
Yes.
is it similar to PERT CPM, sir, the plotting of the graph? PERT program evaluation and
Yes. PERT CPM is little bit different.
okay, sir.
PERT CPM is little bit different, where we are aiming for the critical path,
Yes,
as well as crashing time and crashing costs also.
yes,
But here, that is not the purpose, but that experience working the PERT CPM will be useful here also.
okay, sir.
Okay, sir. Sir, are you sending this board and also data set so that we will practice? And also, we need your email ID. I think you have given, right, sir?
Already I have given. Again, I
Yes,
will be
sir.
posting
We'll be in touch
the
with
chat
you
box.
if you have
Yes,
any...
yes. Please,
yes,
please. Yeah, I will be giving my name.
And this data set also you are sending, sir?
Yeah, definitely. It is all available in the internet also. I have given the source also.
So very good, sir. We are very much knowledge. You gave a very good knowledge to us,
Thank
and
you,
at the
sir.
same time gave a homework to us also to upgrade ourselves.
Yes. It is comprehensive, sir. The code and the details and the PPT. 3 things I will be sending. The code,
in
PPT.
WhatsApp you are sending, sir?
Wait a minute. I will be sending now. See, I have given my details now.
Okay, sir.
I think there is no error. It is not happening here. I think these people are blocking here. Otherwise, I will be sending here itself. I will be sending to you. No problem. Yes. I think they do not know how to. Otherwise, we can finish the work here itself.
Sir, you please share it with us, sir. We will share it with the participants.
Yeah. No problem. I will be sending.
You can send through email ID, sir.
Okay. No, they will send it, sir. They will send it to you. It is all depending on you. No issue. Anyway, I can do. It is not any secret, sir. It is everywhere. It is available. You can see. Only thing is we have to work on it. Continuously, we have to work on it. But you please understand how it was started and how it has ended. This is always there. When it was starting, we are in the mid of the ocean. And now we are in the excitement, isn't it? Now you completely understood about these concepts of 3 concepts, and then how much of importance of lift is, and how much of importance of other things, and how each transaction is influencing, like that. I'm happy that you are all interested, and your interaction is also super high level. You can create more strategies, you can discuss, and you can find out some, you can create your own data set and you can load it and you can analyze it. That is also interesting. You can create your own data set. You can collect your own data set and you ask your students to collect the data set and load it and then do and give some suggestions for the nearer grocery shop also. That is also very good. Okay, anything else?
Thank you so much, sir.
Thank you. Thank you. All the best. You can get the data set, this one PPT, everything I will be sending. They will send
Thank
it
you,
to you.
sir. Thank you, sir.
Thank you, sir. Thank you. Thank you. All the best.
Thank you.
Thank you. Thank you.
Madam? Thank you so much, sir. Any other questions, participants? I think they have already asked too many questions and lots of interactions have happened.
Yeah.
Yes.
Very glad to have you as a resource person, sir.
Yes.
So please stop sharing your screen. We will take a photo.
Okay.
I request all the participants to please turn on the video.
Ramana sir, how are you, sir?
Excellent, sir. We are very much
Thank
happy.
you, sir. Thank
I'll
you, sir.
be discussing with you, sir.
Yes, sir. Yes, sir. Yes, sir. Please.
So to get because MBA is in the top position now.
Yes.
Because of recession.
Yes.
They want business professionals to help them in their business growth.
True, sir. True, sir.
So business MBAs will have a bright future.
Yes, sir. Yes, sir.
The only thing, what you said, upgrade. That is
yes,
the
sir.
thing.
That
It's
is
a must.
That is the yes, sir. Yes.
It's a mandate.
It is not only to anybody. It is for me also, sir.
Yes, sir.
Continuously, yes.
And
yes.
we have to learn from our Prime Minister Modi.
Yes.
He came from
Yes.
Chaiwala. Now people are giving a lectures on ISRO and technology, etc., all those things.
Yes.
How much he is spending time.
Yes, sir.
And if you spend little time, we can rule the world, sir.
Yes, sir. Yes.
I take initiative from him only.
Okay. Yeah.
Because see how much knowledge he gathered, sir.
Yes, sir.
And he is not missing any point. Perfect knowledge he is giving.
Yes, sir.
So please stop sharing the screen.
Sir, stop sharing screen, sir.
I will be doing it.
Over to Brinda for vote of thanks.
Good evening to everyone. I'm Professor Brinda is here to propose the vote of thanks for the day 4 session of FDP on the place analytics. On behalf of the team AMET, I'd like to express my gratitude to our today's resource person, Dr. V. Gajapati sir, for giving a complete insights and coverage with respect to the place analytics. And the participants were really very happy with the session that has been happened on day 3 and day 4. That is with respect to product analytics as well as the place analytics. So, dear participants, I hope this was really an informative session to you all. I would like to thank you all for you being a part of this FTP program. We truly acknowledge your valuable presence and we look forward to same enthusiasm for the upcoming sessions as well. The recording of this particular session will be shared to you all through WhatsApp as well as the email groups. And we request your presence for the upcoming FTP sessions as well. Thank you so much.
Madam, we haven't received a second day, madam. Second day.
I have already shared, sir. I have already shared it on the.
Okay, I'll check it, madam.
And even on the group also I have shared.
Okay. Thank you, madam.
Thank you all. Thank you, sir.
Thank you. Thanks, madam. Thanks, madam.
Thank you so much, sir.
Thank you to all. Thank you, sir.
I will be in touch.
Thank you very much. Yes,
bye.
sir. Yes, sir. Thank you, sir. Bye. I leave.